Okay, this is your basic will the block stay on the plane all by itself question, right? And then I added this. This was a question that was on the AP exam in, like, I don't know, 1985 or something like that, right? I went to some conference and everybody got it wrong. So let me explain what they did and how you can get it right. Okay, so let's see. The block is initially at rest on the plane. Well, let's start to slide down the plane all by itself. Well, as you look at this block on the plane, there is the force parallel of gravity, right? And that force down here, we figured that out as 25.9925. We figured that out in part A. So if you want to know how I got that, it's just mg sine theta, right? And if you want to know why it's mg sine theta, look, we'll go way back, look at the first video. Okay, but anyway, there that is, right? That guy's acting down the plane, right? Now, if it's sitting at rest, this is the only time where this guy gets to shine, your static friction force, right? The static friction force, the static, right, is just simply, it's less than or equal to 27.8698 newtons, okay? That just means it can get as big as that. It doesn't mean that it always is that. It's just that's as big. If you exert a shear force or whatever bigger than that, all those little weak chemical bonds break and static friction is no more, and then we have kinetic friction. Okay, so now the question is, that force is trying to make it move. Is that bigger? Is 25.9925, is that bigger than 27.8698? And the answer is no. Right, so it will stay. It will not slide. It will stay. Will it start to slide down the plane all by itself? No. Okay, this would have to be bigger than that, right? What is the force of static friction that exists between the plane and the block when the block is at rest on the plane? Well, I think like 80% of all the AP students that year just said, oh, well, I calculated the static friction, so there it is. But you got to think about this, right? If that force is acting down the plane, that guy's negative, right? And the forces have to add to zero. Doesn't that mean that there's a force that's equal and opposite acting up the plane? So the force of friction, kinetic, right, is positive 25.9925. Remember, it's less than or equal to this. It's any number less than or equal to this. If they asked what's the maximum static friction, that would be the right answer. If they say what is the static friction, it's just whatever happens to be acting to keep it from moving, right? You have to look at this. It's actually an equilibrium problem. Okay, so yeah, so the answer is positive 26.0 newtons, and it would be up the plane, right? Anyway, there you go. Confusing, isn't it?